All right, number 5. Bubba drops his math book from a 150-foot cliff.
What?
The height of the book after t seconds given by the formula h equals negative 16t squared plus 150. After how many seconds will it take for the book to hit the ground? So when I put this one in, Desmos negative 16x squared plus 150. Y'all are tardy. I know. Hey, we've started. So when you put this one in, Desmos, and again, I'm going to hit the house to go back to normal. What is it asking? What's the question asking on number 5?
After how many seconds will the book hit the ground?
Will it hit the ground? Right here, does it hit the ground at negative 3? No, it hits the ground at positive 3 is when it hits the ground at 3 seconds. Okay, so right there where the x-intercept, that's where it's hitting the ground. All right, so approximately 3 seconds. Okay, number 6, what is the vertex of the parabola y equals x squared plus 4x minus 6? What word should I circle? Vertex. Does anybody remember from the other day what the vertex is? It's either the highest point or the lowest point. And it's not going to have both, right? Because the parabola either opens up and then that's the vertex, or the parabola opens down and that's the vertex, okay? So, you need to put it in Desmos if it's calculator active. And x squared plus 4x minus 6. And if you click down here, what is the vertex? Negative 2, negative 10. All right, number 7. A punter punts a football with an initial velocity of 48 feet per second when he's holding it 4 feet above the ground. How far down the field will the football be after 2 seconds? Okay, this one, do they give you the equation? No, so you have to make your own. Y equals, what comes first? Good. That refers to what? Gravity. Okay. Then what comes next? Good. So what is V? 48x. Okay. And what is the starting height? 4. Okay. This one you can do a couple different ways. How far down the field will the football be after 2 seconds? You can use Desmos. You would just need to trace it with your mouse. You could also use your calculator. What do you think I would need to do with 2 seconds? Plug it in for X. X stands for seconds. Okay, so Omar, when you put it in, you're going to put 2 in for X here and there. Do parentheses. Do parentheses. Yeah, the square goes on the outside of the parentheses. So negative 16, parentheses 2, square goes on the outside. Y'all should have your calculators out. Plus 48 times 2 plus 4. Might have forgot your negative at the beginning. What do you get for this one? Are y'all getting 36?
Yeah.
Okay. All right, number 8, the height in meters of a projectile can be represented by y equals negative 9.8 t squared plus 109.7 t plus 7.4. Models the number of meters y a toy rocket is above the ground 2 seconds after it's being launched. What does the 7.4 represent? Okay, so the 7.4, does it have a letter with it? No. So that is my starting, what? Height. Okay. All right. If you look at your answers, which answer means starting height? A. Initial height is the same thing as starting height. Okay. A punter can kick a football from the ground with an initial velocity of 48 feet per second. When will it reach 20 feet? Again, it doesn't have the equation, so I'm going to have to make my own. What comes first? Negative 16x squared And then your velocity comes next. The velocity is 48. What is the starting height? What's the starting height? Very good. It's 0 because he's kicking it from the ground. So you don't have to put plus 0. I was just trying to make my point. He's kicking it from the ground. When will it reach 20 feet? So do I plug 20 in for x? No. X is the seconds, okay? So you can put 20 here, but there's no way to solve it by hand. Well, there is, but you won't learn that until Math 2. So you're going to have to use Desmos or the calculator. Which one do you want to use? Desmos. Let me show Desmos first, and then we can do the calculator too. Negative 16 x squared plus 48x. And you just click anywhere with your mouse, and you just drag the mouse. And we're trying to find when it does what? 20 feet. So you want to go right till it's at 20. Close enough. So how long does it take to get to 20 feet? 0.5. Half a second. Okay? So on Desmos, it reaches 20 feet at half a second. Do I still need to do the calculator? Okay. For the calculator, you have to go to your y equals and type in negative 16x squared plus 48x. You got to type it in the y equals. Negative 16x squared plus 48x. And then you have to go to second table. And, sorry, I should have gone to second window first. What should I tell it to start at? Okay, so look, you got to remember, this is always an x value. You can only put x values in right here. Is 20 an x value? No, so you can't put 20 in. What would be a good place to start? 0, and then you go to second graph, and you're looking for 20 in the y. Desmos is a lot easier. Do you even see 20 over here? No, so and I don't think I've taught you this yet. Desmos is just a lot better, but you can see where there's this triangle right here. That means delta table. It's what it's changing by. Instead of being 1, what's smaller than 1? 0.5. So you can tell it to go by 0.5. So it starts at 0 and then it counts by 0.5s. So when does it reach 20? At 0.5. Okay. All right. Number 10, you've got a formula. Find the height of the swimmer after 0.3 seconds. All right, is 0.3 seconds an x value or a y value? X. So can you plug it straight in? Yes. Okay. So you would do negative 9.8 and then 0.3 squared plus 3 times 0.3 plus 12. You just type that all in your calculator. You're plugging in 0.3 for x because it's time. Time goes in for x. Okay? Anybody got it? Still typing it in? Good, thank you. What y'all getting? Well, I heard somebody say 10. Oh, you forgot your square. All right, what are y'all getting? 12. Okay. All right. Number 11. A firework is launched from a cliff overlooking the ocean. Then you have an equation. How high is the top of the cliff in feet above sea level? Okay. It's asking how high is the. No, it's not, but good question. Good question. This one says, how high is the top of the cliff? What were you doing on the cliff?
Jumping off.
What was happening on the cliff?
Wow.
You were doing what? You were launching a firework. Okay? So, here's a cliff. Here's a cliff, and you're launching a firework. What does the firework do? Goes up and comes back down. Question number 1 on your notes, if you go back and look at that one, question number 1 said, what is the maximum height of the firework? That's right here. Do you agree with that? Okay, that's the maximum height of the firework. What's this question asking?
The cliff, the X value.
How high is the
Top of the cliff.
the cliff? The cliff's right here. How can I find the cliff?
X value. X value.
Not the x-intercept. It's the y-intercept. It is your starting value. What is the starting value?
Oh.
What is the starting value? 63. Okay. 63. 63 is how high the cliff is, because that is your starting value. Where did the fireworks start from? 63. That's where the cliff is. That's how high the cliff was. Okay. All right, number 12, you're throwing a baseball. It follows the path modeled by negative 16t squared plus 42t plus 6. How high off the ground is the ball when you release it? 6. Very good, because that's another way of asking where does it start from. Okay, when you release it, that is your starting value. Right there, that's your starting value. Starting at 6, okay? How hard are you throwing the baseball? Yep, how far? I'm sorry, what did you say? 42. How hard are you throwing it? Is it speed? This number in the middle is your velocity or your speed, okay? So 42. It does need units with it. Do they tell you if it's feet? They don't, but we'll assume it is feet per second, okay? How long is the ball in the air before it hits the ground? How do you do that one? Desmos. You have to put that one in Desmos. Negative 16 x squared plus 42x plus 6. All right, click with your mouse. Click where is it hitting the ground. Click where is it hitting the ground. 2.7. Okay. No, just do decimals for now. So 2.7 seconds. What is the max height?
The
What is
vertex.
the max? Very good. It's the vertex. So again, we need to use Desmos. So zoom in or out, whatever. I never can remember which way it is. What is the maximum height? 33.5. Okay. What is the height of the ball after it's been in the air for 2 seconds? Is 2 seconds an X or a Y? An X. Okay. So you can plug 2 into the original equation. You can also look in Desmos since you've already got it in there. You're trying to find when X is 2. So you could just trace with your mouse. When X is 2, what is its height? Keep dragging. You want the X value to be 2. You want the X value to be 2. What you got? 26 is one of the answers. I think there might be another one. It might only be 26. Is it just 26?
Yeah, 26.
26.
Sorry. Okay, good job. All right, 26. How long has the ball been in the air when it's 20 feet high? What about 20 feet? Is that an X or a Y?
Y.
That's a Y. So you're looking for 20 in the Y when you're tracing it. You're looking for 20 in the Y. 0.4 is one of the answers. There's 2 answers though. 0.4 is one of them. 2 point what? There's 2 answers because it hits 20 feet when it's going up and it hits 20 feet when it comes back down. So there's 2 answers. 2 right answers. Okay? Okay, last part. Average rate of change. Whenever I see those words. Slope, which is what formula? All right, write it down. Y minus Y over X minus X. Whenever you see rate of change, you have to do that formula. Y minus Y over X minus X. Okay? A projectile travels straight up from a height of 5 feet, initial velocity of 80 feet per second. The height of the projectile as a function of time is modeled by y equals negative 16t squared plus 80t plus 5. What is the average rate of change on the interval 0 to 1? Okay, so what is the keywords? All right, so circle, underline it, highlight it. All right, so I'm doing y minus y over x minus x, okay? What numbers have they already given you?
80. The initial value in the
The
height.
velocity and the
All right, they give us the velocity.
and the initial.
I guess what I'm asking is, do I know the two things that go in for these y?
No.
Do I know the two things that go in for this x?
Yeah.
Yeah.
It's
Negative
negative
16 and 80.
I mean,
Then
I don't know.
Zero
That's
and
what-
one?
Oh, no, it's 80.
0 and 1. Good job, whoever said that. So, right here, if you look, they want the x to be 0 and 1. That's what they want the x value to be, 0 and 1. Okay? I'm going to make a little chart just so everybody understands what's happening. So when x is 0, let's figure out what y is going to be. Okay? When x is 0, instead of using x, they're using a t. Okay? If you plug in 0 here, what do you get? 0. What about here? What's 0 plus 0? Plus 5? So you get 5. Okay? Could you do that in your calculator if you wanted to? Sure. Okay? All right, what about when x is 1? Okay, if I plug in a 1 here, then I get what? Negative 16. What about when I plug in 1 to the middle? 80. And then plus 5. What does that give you? Yes. Okay. So when I put it into the formula, 69 minus 5, 1 minus 0. It doesn't matter what order you do as long as you're consistent. 69 minus 5 is 64. 1 minus 0 is 1. What is 64 divided by 1? 64. Okay. Question? All right, last one. What is the average rate of change from x equals 2 to x equals 4? What's the formula for rate of change? Okay, we know the x values are 2 and 4. Those are your x values. How am I going to find the y? The graph. Very good. So, when x is 2, what is your y value? 0. When x is 2, your y value is 0. What about when I go to 4?
6.
Very good. It's at 6. Okay? So 4 and 6. Okay? All right, 0 minus 6 is negative 6. 2 minus 4. And then when you divide that, you get